Hi everyone, welcome back to the channel. Let's discuss ANOVA today. We already discussed the student C test. It is generally used for comparing two groups, but when more than two groups are compared, then ANOVA is used. It is a parametric test just like student's D test. ANOVA is short for analysis of variance. It compares the variance between the groups to the variance within the groups. There are two terms, factors and levels, associated with ANOVA. Factors is the number of treatments we are giving. For example, if I'm measuring the effect of the diet on the weight of a person, then diet is a factor. And since only one factor is being considered, it is termed as one way ANOVA. But if more than one factor is used, for example, I'm measuring the effect of diet as well as of exercise on weight, then it uses two-way ANOVA. Level is the value of factor that we use. For example, I may take different kinds of diet or different doses of a drug or even different periods of exercise. Now let's go to the calculation part step by step. I will take the example of measuring the effect of three different diets on weight. Step 1. Form the null and alternative hypothesis, which will be that the diet does not and does affect the weight respectively. Step 2. Perform the experiment and collect the data. Step 3. Select an alpha level, which I will choose to be 0.05. Step 4. Calculate the degrees of freedom. In ANOVA, there are two kinds of degrees of freedom. One corresponding to the number of groups and the other corresponding to the number of samples in each group, also known as numerator and denominator degrees of freedom respectively. So the numerator degrees of freedom will be the total number of groups minus 1, which will be 3 in our case, and the denominator degrees of freedom will be addition of degrees of freedom in each group, which will be 16. It can also be calculated as total number of samples n minus total number of groups k. Step 5. Find out the F critical. Just like we had t-score in t-test, we have F statistic in ANOVA. For easier understanding, F statistic corresponding to the alpha level is termed as F critical. In case of ANOVA, different F distribution tables exist for different alpha levels. This is a table for alpha level 0.05. Here the row corresponds to the denominator degrees of freedom, which is 16 in our case, and the column represents the numerator degrees of freedom, which is 3 in our case. Considering this, the F critical will be 3.24. Step 6. Calculate the F statistics by the following formula. MSB is mean squares between groups, calculated by dividing sum square between groups SSB to numerator degrees of freedom k minus 1. Whereas MSW, that is mean squares within groups, is calculated by dividing sum squares within groups SSW to denominator degrees of freedom n minus k. SSB is calculated by the formula. First, we take mean of all group means and then take the difference of each group mean from the final mean multiplied by each group sample size, followed by addition of all the resultant values. MSB will be SSB divided by numerator degrees of freedom 3. SSW is calculated by multiplying variance of each group to their respective degrees of freedom and then summing up all values. MSW will be SSW divided by denominator degrees of freedom 16. So in short, we will have the following values and the ratio of the MSB to MSW will be F statistic of the data. Step 7. Compare F statistic and F critical. Here, F statistic is more than F critical. In the graph, it means that the probability area for F statistic, that is p-value represented by green area, will be less than the probability area for F critical, that is alpha level, represented by orange area. Since p-value, that is the probability of getting the data if the null hypothesis is true, is low, therefore we will reject the null hypothesis. Step 8. Post-hoc test. Now we know that the alternative hypothesis is true, but we still don't know which diet reduces the weight. You see, ANOVA only tells that the groups are significantly different from each other, and that's the only role that ANOVA has to play in statistics. But which group is different, it doesn't tell. For that, we use post-hoc tests such as Bonferronis test, Tukey test, Dunnett test, etc. So make sure that after conducting ANOVA and finding out that the groups are significantly different from each other, use a post-hoc test as well. That's it for today. Thanks for watching. If you learned something from this video, please like, share, and subscribe.